Now we will try to see the next type of recursion, that is nested recursion. The definition of nested recursion is a recursive function is a recursive function where the argument passed to the function is the function itself. Let's say we were defining a method is even. In is even, we have given the argument as int n. Instead of giving the argument as int n, if we give the argument as is even, for a is even method, we are giving the argument as is even. So when the argument is passed to the function is the function itself, then it is called a nested recursion method. Nested recursion method is not used very widely, but because we have this method called a nested recursion, we are trying to understand this nested recursion. There is a standard function called Ackerman function which we use to understand the nested recursion. So let's look at what is an Ackerman function. I am calling Ackerman as A. Instead of saying Ackerman every time, I will say A of n comma m. A of n comma m is m plus 1 if n is equal to 0. A of n comma m is A of n minus 1 comma 1 if n greater than 0, m is equal to 0. And similarly, A of n comma n is A of n minus 1 comma A of n comma m minus 1 if n greater than 0 and m greater than 0. Here we can see this is a nested function. A of n minus 1 comma A of n comma n minus 1. The function is given as a parameter to the function itself. Here what we want to remember is there are two variables n comma m. There are some cases. First case is when n is equal to 0 and m is equal to 0. Let's say when n is equal to 0, the output is m plus 1. When n is greater than 0, when n is 1, 2, 3, 4, 5 or anything, but m still remains as 0, then the output is A of n minus 1 comma 1. When n and m both are greater than 0, n and m are both 1, 2, 3 or any other value, then we call the nested recursion. So we will try to write the code for it. These conditions we will write in the Java code as it is. So I am writing the code in the same program, same project. I am naming it as nested recursion. As usual, the first step what we do is we will store the result of the method in a variable result. So int result is equal to Ackerman. Instead of calling it as Ackerman every time, when I say Ackerman, that implies it is ACKM. I am writing it as ACKM. So Ackerman of 1 comma 2. So I am calling a method Ackerman with parameters 1 comma 2. 1 comma 2 are the values for n and m. Then I am writing the output system.out.println give an output of Ackerman function of 1 comma 2 is result. So now we will define the method public static, because this is returning a value of int type, int Ackerman of the variables are also of int type, int n comma int m. The first condition is a of n comma m is equal to m plus 1 when n is equal to 0. When n is equal to 0, the output is m plus 1. So we have to return output m plus 1. Else if n greater than 0 and m is equal to 0, n greater than 0 and m is equal to 0, output is Ackerman of n minus 1 comma 1. Else if n greater than 0 and m is equal to 0, output is Ackerman of n minus 1 comma 1. Else in the sense when n is greater than 0 and m is greater than 0. First condition we are giving when n is equal to 0. Second condition we are giving when m is equal to 0 and n greater than 0. So the condition that is left is when n is greater than 0 and m is greater than 0. So we don't have to explicitly say that n is greater than 0 and m is greater than 0. The output is this, we have to remember. A of n minus 1, so this is the same, a of n minus 1, first parameter is the same, comma, a of n comma n minus 1, a of n comma n minus 1. So return a of n minus 1, this is the same, then a of n comma m minus 1. Okay, so now we have defined the method. We will understand it in a little while, but we will just try to run the program. As I have said, when there is a recursive call, we will get a symbol at the left side. This is the symbol I was talking about, recursive call. This says that Ackerman function is calling Ackerman function. The function is calling itself. So here also Ackerman function is calling Ackerman function. It is a recursive call. Whereas in an indirect recursion, we did not find this symbol. We were actually writing a code for recursion, but we were writing in an indirect method. So we did not see this symbol. So we will try to run this code and understand how we actually get the output. So Ackerman of 1 comma 2 is 4. Ackerman of 1 comma 2 is 4. So now the challenge is we want to understand how we got this 4. So now we will go back to the PPT. So this is the definition of the method. So now we are calling a of 1 comma 2. When a of 1 comma 2, here n is greater than 0 and m is greater than 0. N is 1, m is 2. So that falls in this third category. So we are calling a of n minus 1. N is 1, n minus 1 is 0. A of 0, comma, a of n comma m minus 1. N is 1, a of 1, m minus 1. M is 2, m minus 1 is 1. So a of 0, comma, a of 1 comma 1. So in order to find the value of a of 0 comma a of 1 comma 1, first we need to have the value of a of 1 comma 1. So a of 1 comma 1, a of 1 comma 1 is nothing but a of 1 comma 1 is treated as a of n comma m. N is 1 and m is 1. So n and m are both greater than 0. That falls in the category of the third category. So a of n minus 1, 1 minus 1 is 0, comma, a of n is 1, and m minus 1 is 1 minus 1 is 0. So a of 0 comma a of 1 comma 0. Now we want the value of a of 1 comma 0. A of n comma m, where we are trying to find n is 1 and m is 0. So this comes in the second category. M is 0 and n is 1, that means n is greater than 0. That is a of n minus 1 comma 1. N is 1, n minus 1 is 0. So a of 0 comma 1, a of 0 comma 1. So that falls in the first category when n is 0. When n is 0, the output is m plus 1. M is nothing but 1. A of 0 comma 1, that means a of n comma m, n is 0, m is 1. So when n is 0, the output is m plus 1. M is 1, m plus 1 is 1 plus 1, that is 2. So this is not the output of a of 1 comma 2. 2 is the output of a of 0 comma 1. So from a of 0 comma 1, we have to do backtracking and find the value of a of 1 comma 2. So we do it like this. A of 0 comma 1 is 2. This 2 we will replace it here. This 2 will replace it here first. A of 1 comma 0. This is nothing but we can replace it here. So that implies a of 0 comma 2. A of 0 comma 2. What is a of 0 comma 2? A of 0 comma 2 is when n is equal to 0, output is m plus 1. M is 2, m plus 1 is 3. So we got the output as 3. A of 0 comma 2 is 3. A of 0 comma 2 is 3. Then that value we will replace it here. A of 1 comma 1 is nothing but a of 0 comma 2. A of 1 comma 0 is 2, right? So a of 1 comma 1 is a of 0 comma 2. A of 1 comma 1, a of 1 comma 1 is 3. So that implies a of 0 comma 3. So a of 0 comma 3 is n equal to 0 and m equal to 3. That implies m plus 1 is 4. So a of 0 comma 3 is 4. That is nothing but a of 1 comma 2. So a of 1 comma 2 is 4. This is how we got the output. Let's just not worry that in the first time only we understand this program. This is a little bit complicated. So we will go through it over again and again till we understand. So again we are trying to understand the same function but in a different way. The first method that we will call is main method. Then the function Ackerman function of 1 comma 2 is called. Let's see in the code. First method is main method. In the main method we are calling the function Ackerman of 1 comma 2. Ackerman of 1 comma 2. Then the recursive calls start. So for a of 1 comma 2, what happens? A of 1 comma 2 is nothing but a of 0 comma Ackerman of 1 comma 1. We can see from the definition here, when n and m are greater than 1, the output is a of n minus 1, 1 minus 1, 0, and a of n comma m minus 1. N is 1, m is 2, m minus 1 is 1. So Ackerman of 1 comma 2 is nothing but Ackerman of 0 comma Ackerman of 1 comma 1. Here we have the value Ackerman of 1 comma 1, as 3. So we have written the value Ackerman of 0, 3, that is equal to 4. Okay, here we have this Ackerman of 1, 1. Now let's see what is Ackerman of 1, 1. Ackerman of 1, 1 is 1 minus 1, 0, and A of 1, 1 minus 1, 0. So Ackerman of 0, Ackerman of 1, 0. So now we want Ackerman of 1, 0. 1, 0 falls in the second category, A of n minus 1, 1. N is 1, 1 minus 1 is 0, and m is 1. So Ackerman of 0, 1. Ackerman of 0, 1, this is the base condition. N is 0 and m plus 1 is 1, 2. So A of 0, 1 is 2. A of 0, 1 is 2 is substituted here. And A of 0, 1 is nothing but A of 1, 0. So Ackerman of 1, 0 is 2, we substituted here. So Ackerman of 0, 2 is 3. That is nothing but Ackerman of 1, 1, that is 3. So the output is 4. So if you pay a little attention and follow this step by step, take a paper and pen and try to write the steps step by steps. Play the video again and again, once or twice, till you understand. Then you will be able to understand how this nested recursion is written. Lastly, we will try to understand the same thing again by writing the outputs by running the program in a debug mode. Who knows, we will understand it, the program better at that point of time. So this is the program. What I will do is I will try to write the code from a program which I have already stored, so that I can avoid any kind of mistakes. This is nested recursion. Yeah. So the same program, I am just adding 3 lines here. I'll just show you. I didn't yet add the lines. See, I am just adding 3 lines. System.out.println of Ackerman of n, m. System.out.println of Ackerman of n minus 1, 1. And system.out.println of Ackerman of n minus 1, Ackerman of n, m minus 1. Just to save some time, I have just copied the code. Lastly, we'll just try to run the program and understand how this is working. See, Ackerman of 1, 2 is the same thing. I'm just iterating it again and again so that we can understand it better. It's calling the method Ackerman of 0, Ackerman of 1, 1. So n minus 1, Ackerman of n, m minus 1. Let's see if that is the definition. See, A of n minus 1, A of n, m minus 1. Then this is calling the method Ackerman of 1, 1. This is the second condition. This is the same condition. N is greater than 0, m is greater than 0. So Ackerman of n minus 1 is 0, n, m minus 1 is 0. And Ackerman of 1, 0. This is the second condition. Ackerman of n greater than 0, m equal to 0, Ackerman of 1 comma 0. Here it is n minus 1 comma 1. N minus 1 is 0 and 1. So that is calling Ackerman of 0 comma 1, 0 comma 2, 0 comma 3. When n equal to 0, the output is nothing but m plus 1. So here the output is 2, here the output is 3, and here the output is 4. 4 is the final output that we want. So this is about nested recursions. Now we will discuss another kind of recursion called excessive recursion. We are left with two more recursions: excessive recursion, tail recursion, and we have got this iterative methods and the big O analysis. Let's just confirm it from the slide. Yeah. On recursion, we have five types: direct, indirect, nested, excessive, tail. Now we have discussed till direct, indirect, and nested. Now we will go. Now we will move ahead and discuss excessive and tail recursions. After that, we will understand how recursive method can be written as a iterative method. Then we will do a big O analysis and try to understand which method we should use, which type of recursion we should use, so that we are writing the program in the most efficient way. Then that concludes session 1 on recursion.